Alright, letter E. Yesterday we learned that the degree of the polynomial is, what's our degree, class? 4. So let's put down here 4. We learned to do this little math problem that the real plus the imaginary equals the degree of the polynomial, fourth degree polynomial. So I need 2 reals times, because this word looks like times, what number? 2. 2 times 2 gives me 4 reals. So that's equal to 4 reals. Therefore you have how many imaginaries? 0. 0 plus 4 equals 4. Okay. Now remember, a fourth degree polynomial, a quartic function, is this an odd or an even number? This is an even degree polynomial. Class, show me with your fingers, what is the easiest even degree polynomial? Thank you for showing me your fingers. It is an x to the second power. The arrows, they call this the end behavior. These arrows is based off this number. So all even degree polynomials are going to have those arrows. So for our problem, let's go ahead and draw that for E and F. Now in these problems, it doesn't tell us if it is a positive A value or a negative A value. So let's just do one of each. All you need to know is that even degree polynomials, you have them both up or both down. Okay, the next thing is the number of reals that's stated here tells you how many dots or colors. Dots or colors. So 2 reals means I'm going to have 2 colored dots. I'll use pink and I'm going to use orange. The number of reals tells you how many dots on the x-axis. And then as I sketch, I'm going to be using a pencil. So I can focus that for you. And it's kind of like connect the dots. You're going to start on the left side, and my connecting the dots, I have to end up at this arrow. Okay, so we're going to go from left to right. And let me show you how this multiplicity works. As I start here, I'm approaching this pink 0, x-intercept. And it has a multiplicity of 2. Class is multiplicity of 2 an even or odd multiplicity? That is an even number. So I'm going to go towards the pink and we're going to bounce or kiss. Okay? This is how it works. You're with your special someone. The lights are going down. You like each other. You've looked at each other once. You kiss and you run away. Now, quartic functions, we've already completed this one yesterday. It looks like W's. What do they look like, class? W's. And I'll explain why in a second, but I need to have another turning point or extrema. And then this orange one, because I'm trying to end up over here, this multiplicity, class, is this even or odd? We're going to bounce or kiss off the orange and end up at our blue arrow there. So this is my quartic function with 2 reals with a multiplicity of 2. Okay? So go left to right, have start and end, and then the number of real zeros and their multiplicity will tell you what's going to happen. Okay? Let's try letter F. Class, if I add these 2 together, it has to equal what number? 4. What number has to go there then? 4, right? Because it doesn't tell us. So therefore, how many reals?
0.
Real is 0. 0 plus 4 equals 4. Okay. This tells you the number of dots on the x-axis. How many dots am I going to draw on the x-axis, class? 0. Okay. Try to sketch out a W. But in this case, it's inverted, so it's an M. How do you draw an M not crossing the x-axis? You try it. Remember, cannot touch. Let's get a color. Can't touch the red line. So here's what mine might look like. And let me explain to you guys why it has to be a W for fourth degree polynomials. This, as I point to it, what vocabulary word would you guys describe these as? Everyone say extremas. Count with me. Ready, set, go. So we have 3 extremas. We have a formula from our formula sheets. Partner A to partner B, what do you think the formula we're going to use? Class, what's our formula? Yeah, the most number of extremas is degree minus 1. So extrema equals degree minus 1. And then if I just put in 3 here, I have 3 equals degree minus 1. Class, how do I get degrees by itself? How do I solve for that? We're going to add 1. So I have a 4th degree polynomial. So the reason why a 4th degree polynomial looks like a W is because it must have 3 extremas. Okay? So there are 2 examples, E and F, of how to graph a quartic function based on the zeros, and then you graph it.